Renewable energy is energy derived from natural sources that are replenished at a higher rate than they are consumed. Sunlight and wind, for example, are such sources that are constantly being replenished. Renewable energy sources are plentiful and all around us. Fossil fuels, coal, oil, and gas, on the other hand, are non-renewable resources that take hundreds of millions of years to form. Fossil fuels, when burned to produce energy, cause harmful greenhouse gas emissions, such as carbon dioxide. Generating renewable energy creates far lower emissions than burning fossil fuels. Transitioning from fossil fuels, which currently account for the lion's share of emissions, to renewable energy is key to addressing the climate crisis. Renewables are now cheaper in most countries, and generate 3 times more jobs than fossil fuels. Awareness around climate change is shaping the future of the global economy in several ways. Governments are planning how to reduce emissions, investors are scrutinizing companies' environmental performance, and consumers are becoming conscious of their carbon footprints. But no matter the stakeholder, energy generation and consumption from fossil fuels is one of the biggest contributors to emissions. Therefore, renewable energy sources have never been more top of mind than they are today. 5 types of renewable energy. Renewable energy technologies harness the power of the sun, wind, and heat from the Earth's core, and then transforms it into usable forms of energy like heat, electricity, and fuel. Wind turbines use large rotor blades, mounted at tall heights on both land and sea, to capture the kinetic energy created by wind. When wind flows across the blade, the air pressure on one side of the blade decreases, pulling it down with a force described as the lift. The difference in air pressure across the 2 sides causes the blades to rotate, spinning the rotor. The rotor is connected to a turbine generator, which spins to convert the wind's kinetic energy into electricity. Wind energy harnesses the kinetic energy of moving air by using large wind turbines located on land onshore or in sea or freshwater offshore. Wind energy has been used for millennia, but onshore and offshore wind energy technologies have evolved over the last few years to maximize the electricity produced with taller turbines and larger rotor diameters. Though average wind speeds vary considerably by location, the world's technical potential for wind energy exceeds global electricity production, and ample potential exists in most regions of the world to enable significant wind energy deployment. Many parts of the world have strong wind speeds, but the best locations for generating wind power are sometimes remote ones. Offshore wind power offers tremendous potential. Solar photovoltaic. Solar technologies capture light or electromagnetic radiation from the sun and convert it into electricity. Photovoltaic PV solar cells contain a semiconductor wafer, positive on one side and negative on the other, forming an electric field. When light hits the cell, the semiconductor absorbs the sunlight and transfers the energy in the form of electrons. These electrons are captured by the electric field in the form of an electric current. A solar system's ability to generate electricity depends on the semiconductor material, along with environmental conditions like heat, dirt, and shade. Solar energy is the most abundant of all energy resources and can even be harnessed in cloudy weather. The rate at which solar energy is intercepted by the Earth is about 10,000 times greater than the rate at which humankind consumes energy. Solar technologies can deliver heat, cooling, natural lighting, electricity, and fuels for a host of applications. Solar technologies convert sunlight into electrical energy either through photovoltaic panels or through mirrors that concentrate solar radiation. Although not all countries are equally endowed with solar energy, a significant contribution to the energy mix from direct solar energy is possible for every country. The cost of manufacturing solar panels has plummeted dramatically in the last decade, making them not only affordable but often the cheapest form of electricity. Solar panels have a lifespan of roughly 30 years, and come in a variety of shades depending on the type of material used in manufacturing. Geothermal energy originates straight from the Earth's core heat from the core boils underground reservoirs of water, known as geothermal resources. Geothermal plants typically use wells to pump hot water from geothermal resources and convert it into steam for a turbine generator. The extracted water and steam can then be re-injected, making it a renewable energy source. Geothermal energy utilizes the accessible thermal energy from the Earth's interior. Heat is extracted from geothermal reservoirs using wells or other means. Reservoirs that are naturally sufficiently hot and permeable are called hydrothermal reservoirs, whereas reservoirs that are sufficiently hot but that are improved with hydraulic stimulation are called enhanced geothermal systems. Once at the surface, fluids of various temperatures can be used to generate electricity. The technology for electricity generation from hydrothermal reservoirs is mature and reliable, and has been operating for more than 100 years. Hydropower. Similar to wind turbines, hydropower plants channel the kinetic energy from flowing water into electricity by using a turbine generator. Hydroplants are typically situated near bodies of water and use diversion structures like dams to change the flow of water. Power generation depends on the volume and change in elevation or head of the flowing water. Greater water volumes and higher heads produce more energy and electricity, and vice versa. Hydropower harnesses the energy of water moving from higher to lower elevations. It can be generated from reservoirs and rivers. Reservoir hydropower plants rely on stored water in a reservoir, while run-of-river hydropower plants harness energy from the available flow of the river. Hydropower reservoirs often have multiple uses, providing drinking water, water for irrigation, flood and drought control, navigation services, as well as energy supply. Hydropower currently is the largest source of renewable energy in the electricity sector. It relies on generally stable rainfall patterns, and can be negatively impacted by climate-induced droughts or changes to ecosystems which impact rainfall patterns. The infrastructure needed to create hydropower can also impact on ecosystems in adverse ways. For this reason, many consider small-scale hydro a more environmentally friendly option, and especially suitable for communities in remote locations. Biomass. Humans have likely used energy from biomass or bioenergy for heat ever since our ancestors learned how to build fires. Biomass organic material like wood, dry leaves, and agricultural waste is typically burned but considered renewable because it can be regrown or replenished. Burning biomass in a boiler produces high-pressure steam, which rotates a turbine generator to produce electricity. Biomass is also converted into liquid or gaseous fuels for transportation. However, emissions from biomass vary with the material combusted and are often higher than other clean sources. Bioenergy is produced from a variety of organic materials, called biomass, such as wood, charcoal, dung and other manures for heat and power production, and agricultural crops for liquid biofuels. Most biomass is used in rural areas for cooking, lighting, and space heating, generally by poorer populations in developing countries. Modern biomass systems include dedicated crops or trees, residues from agriculture and forestry, and various organic waste streams. Energy created by burning biomass creates greenhouse gas emissions, but at lower levels than burning fossil fuels like coal, oil, or gas. However, bioenergy should only be used in limited applications, given potential negative environmental impacts related to large-scale increases in forest and bioenergy plantations, and resulting deforestation and land use change.